This is H-115 Troubleshooting Relay Circuits. And you see here we have our power board from the starter kit H-111A, and we have plugged in our fuel pump relay circuit. And to make this more interesting for troubleshooting, we identify the relay as the fuel pump relay, and the lamp circuit here is going to be the fuel pump motor itself. So the fuel pump is controlled by the relay, which is controlled by the circuitry here. If I turn the ignition switch on, you'll see the relay click. Of course you didn't see that, but maybe you heard the click. Listen for the click. Now it's hard to hear the click because it's not very loud, but it's an important part of troubleshooting relays that you identify, confirm that the relay did click or did not click. And I'll show you that here just a little bit as to why that's so important. And of course the relay contacts close, the lamp lights up to simulate that the fuel pump is running. So this circuit is quite unique in the sense that relays are actually two circuits at the same time. They're just not one circuit. Like the first circuit with the lamp, that was a single circuit, and then with the DC motor, it was a single circuit. There was one load, one circuit, one switch. But here with relays, we have two circuits. We have the control circuit of the relay coil, and I call that the primary circuit of the relay, and the relay contacts are the secondary circuit, which controls the fuel pump, in this case, or the light. Now, there's a lot of things that can go wrong with a relay circuit because you have more than one circuit. You have two. We have a total of 75 relay circuit problems to troubleshoot in this particular circuit. And as I turn the boards over on the bottom, you'll see here all the different jumpers. Of course, the jumpers on the power board, they're the same. But here on the relay board, we have a number of problems that can be inserted. I mean, we can go through more things about relay failure than you ever would have thought about. And we will show you how to successfully troubleshoot each one of those. This workbook is about 116 pages. It's the largest workbook of all the workbooks that come with the different circuit boards. But for H-115, you would get a relay board, the student workbook, WB-115, and a resistor bag to have be able to insert the problems. The instructor guide that comes with the H-115, it has all the answers to all the exercises. It has all the answers to every troubleshooting problem and instructions in how to insert each of the problems. And we're going to troubleshoot one problem at a time. The only time we troubleshot more than one problem at a time was in the last module with the DC circuit board, the DC motor board, excuse me. And so, but now we have two circuits, and it's conceivable you could have two problems. And we're going to discuss those one by one. There's a number of exercises you will go through step by step, analyzing all the different possible options that you could run into before the time comes to start troubleshooting the 75 different problems. And in this particular situation, what we have done, looking here at the workbook, I opened just at page 45, but I want to go past that. And here we are into the problem pages, and at the top of each page is the problem number, and under that, in italics, is a customer complaint. In other words, if this relay circuit was his fuel pump circuit, depending on the problem that we put into the relay circuit, this is how the car would act if that were the actual problem in the customer's car. And then you see places to write down your troubleshooting steps, just like with the other modules, and then at the bottom you write down a summary of what you found as the problem. So troubleshooting, again, having troubleshot two different circuit boards, you have already been exposed to much of the troubleshooting you're going to need to do in the relay circuit. But there's some things here that we need to talk about. In other words, how does a relay work? Well, let's see, I think you can see that. Yeah. A relay at rest, the contacts are open. When electron current flows through the relay coil, an electromagnetic field is created, magnetizes the contacts, which close, turning the circuit on. And then when you break the current to the coil, the field collapses and the contacts open and shut the circuit off. And when the field collapses, that's the problem we have to deal with. So then we go into a discussion of the electromagnetic field around a coil, how it builds up, and then when it collapses, if it's not controlled, it would destroy the control unit that is providing the current through the relay coil. And the way they do that is they put a diode across the relay coil, and the discussion here on pages 5, 6, 7, 8 explain that, what's going on. And you'll see here you have the option of using a diode for relay suppression, spike suppression, or you could use a resistor. And the pros and cons of each one is discussed here so that you could thoroughly understand that. Because this is a factor that has been overlooked. In the early days of automotive electronics, there were some circuits that were not spike protected and they were damaged, and there was quite a few failures they should have never had until they finally realized that these relays, as simple and as low power as they are, when that field collapses, the energy dump can be sufficient enough to knock out a driver transistor. So it becomes incumbent on us as technicians to recognize the kind of failure we have in the vehicle, and when we see it's a relay that isn't being controlled, the possibility is that the diode inside the relay itself is bad, the spike suppression diode is bad, or the spike suppression resistor is bad. Basically they'd be open, and so there was no spike suppression, and the technician comes along and sees, okay, the relay is not being controlled, the computer with the driver transistor that controls the current through the relay coil is dead. I need a new control unit. So you plug in a new control unit, leaving the defective relay in the vehicle, and within a day or so the defective relay knocks out the new computer that you put in there. So this becomes a big issue, and our intent here is to explain this in detail, because you as a technician that have been trained by Beeger Enterprises, we don't want you to be exposed to something you can't find or you can't explain why. And this is part of the rationale behind our in-depth analysis of spike voltage suppression and how to test it, how to check it. On page 15, we're back into ohm meters again. Now here's where the ohm meter really becomes a valuable tool. This is something you're going to have to study and read and digest, and also practice if you happen to have an analog ohm meter. If I were working in the field in this day and age, I would have in my toolbox, properly protected in a plastic box of some kind, or the original box, I would have an analog ohm meter like you see pictured here, so that I could test a spike suppression diode inside the relay. So we go through an analysis of first using the analog ohm meter, then using the digital ohm meter, and showing you that the digital ohm meter cannot check the diode inside the relay. And it also explains why some people mistakenly believe that the diode test feature of your digital meter will test the spike suppression diode, and it will not. And you need to know that. And this explanation will tell you why and help you to fully understand it. So that's a big part of the initial discussion and training concerning relays. Everything else is very much the same that we did with the DC motor board and the lamp board. So here we are with our relay circuit. Now we're just doing our standard troubleshooting like we've done with every other circuit that we have been studying so far. Because the Texas two-step still has a place in a relay circuit troubleshooting. You just got to do it twice because you have two circuits. So let me give you a quick synopsis of what you're going to study. If the relay clicks, you don't have to check pin 86 and pin 85 on the relay, which are the coil. You've already read that in the first few pages of the workbook. And the reason you don't have to check 86 and 85, it's already working. The relay clicks. The relay clicks because you have proper voltage on 86, and here you see 12.88 on pin 86, and then on pin 85 you have 0.04, which is a good ground. So the relay coil circuit, the primary circuit, is good. And of course we've got a good circuit here. Notice the fuel pump. Now if I want to know if the fuel pump is getting everything it needs, I check pin 1, which is FP1, fuel pump pin 1, and I see 12.74. That's good voltage. And then I go to FP2, which is the ground pin, and I see 0.05. That's a good ground circuit. So the circuit right now is working fine. However, let's suppose that the relay clicks, but the fuel pump doesn't light. The fuel pump doesn't run. What do? You do the Texas two-step. You look for voltage on FP1, you look for ground on FP2. One of those two readings is going to tell you why the fuel pump is not running, or if it's running weak, which means the lamp would be dim. So it's the same thing again. You have a primary circuit, and then you have the secondary circuit. The Texas two-step on the primary circuit will show you why the relay is not clicking. And then if it's not clicking, there's no point coming over to the fuel pump and checking. Of course it's not running because the relay contacts have not closed. So whether the relay clicks or not is a crucial part of understanding the circuit. If you've got a circuit that's relay controlled and it's so noisy you can't tell if the relay clicks or not, what I have done is taken a screwdriver and put it on the relay housing itself and put it up to my ear and then turn the relay on and off with the circuit that the relay is operating, and see that it clicks or not by listening with the screwdriver pressed against your ear. You can also buy one of those stethoscopes which allows you to probe the top of the relay and definitely hear the click when it occurs. And if this relay does not click, then I'm supposed to check pin 86 and 85 at the relay coil to find out which one of those is preventing the relay from clicking. However, if the relay clicks, then something's wrong with the fuel pump. It's either weak or it's not working at all. I go to FP1 and FP2 on the fuel pump, and one of those two readings will tell me why the fuel pump circuit has a problem. Once I identify which side of the circuit has the problem, I simply trace back, finding my voltage, or tracing back, finding my ground on both circuits, and you will find the problem. But you have to have a logical sequence. And what we're going to teach you in those 75 practice troubleshooting problems, we're going to teach you by repetition. Do it the same way every time, and you will not have a problem finding the problem in a relay circuit. Wherever we put it, whatever we do to it, you can find the problem. And that's just because we understand how circuits work, we understand how circuits fail, and we've given you a systematic troubleshooting procedure. Of course, with the relay, we have a new concept, and that is a spike suppression diode or resistor inside the relay itself, which is crucial. If that has a problem, that relay has a problem, and when the field collapses, it's not suppressed with a diode or a resistor, then it could damage a control unit, and replacing the control unit will appear to fix the problem for about a day or so, but every time that relay powers down, it's going to jolt the driver transistor and kill that new computer that you just put in the vehicle. So that's why we emphasize so much the importance of checking that spike suppression diode. And I'm going to give you a little quick synopsis of that. I'm going to power the circuit down because, as you will read in the workbook, you never probe your ohm meter into a live circuit. Okay, I've got my little analog VOM here. I'm on times 10 and I zero. I think you can see the pointer a little bit. We can maybe enhance that after we get the video produced. Okay, now one of the things you're going to learn about analog meters, let me say analog ohm meters, is they are backwards. In other words, when you see a red and black probe, you automatically assume that the red is positive and the black is negative. Now that is true if you're measuring voltage, if your meter is set to voltage. But when you select it to ohms, backwards. Black is positive, red is negative. Now there's a story why that is. You know, I could tell you the story, It puts you to sleep. We don't care. We just know, excuse me, we just know analog ohm meters are backwards. So I use the statement to myself to remember this. When I get ready to do a measurement of a solid state circuit, as I hold the probes in my hand, I'm right-handed, so I put the black probe in my right hand and the red probe on my left hand, and I say to that black probe, black is positive, to remember that the analog ohm meter is backwards. Okay, now, the diode is right across the relay coil. You're going to read about that in detail by the time you get here. So, when the pin 86 is positive and pin 85 is negative, that's the polarity that turns on the relay, correct? Yes. Okay, so I'm reading right now 400 ohms. That is the resistance of the relay coil. I am not reading through the diode. The diode is off when the relay is on. Now, to simulate the collapsing magnetic field, I reverse the probes of the ohm meter, and I put negative to 86 and positive to 85, and you see the pointer on the meter go down to about 55 ohms. That's the diode turned on. I have just proven that the diode inside the relay is good. If I had a reading of 400 both ways, I would know the diode is open. It's not working. So you see, you can't get along without an analog ohm meter. You can verify a diode across the coil. But let me show you something now about the diode test. If I take my digital meter and I dial diode test, and I short my probes together to make sure it's working. Okay, see, it goes to 0, because right now I've got no connection, nothing between the probes. Now, on the diode test, red's positive, black's negative. So I'm going to put the positive to 86 and the negative to 85, which is the polarity that turns on the diode, turns on the coil, and at that time the diode is off. So you see, I'm reading 441, which is nothing more than the 400 ohms of the relay coil. So the diode's off right now. Now, if I reverse the leads and put the negative to 86 and the positive to 85, which is the polarity of the field collapsing, the diode should turn on and I should see a lower reading, but I'm still seeing 430 ohms. So the diode test will not check the diode across the coil. The only tool that will do that is El Cheapo Analog VOM. And that little bit of information is something that nobody ever talks about anymore. But you, as a high-level electrical systems troubleshooter, you're going to understand that and you're going to do it correctly. So, as we go back to the circuit and we do our voltage measurement, I can certainly take advantage of a lot of possibilities for analyzing the circuit. Here I'm going to be checking the voltage drop of the voltage side. Be careful, I don't want to short those pins together, so let me just go this way. From pin 86 to the B plus terminal, and my voltage side to the relay coil is 0.77 volts, which is a good reading. That tells me I don't have a bad connection. If I did have a marginal connection somewhere on the voltage side of the relay coil, this reading would probably be a little bit higher than 0.77. To give me a clue that there's something going on here, I would wiggle, twist, tug on the wire harness, and if there is a loose connection, when I move the harness, this reading will jump around and give me an instant indicator that's where the faulty connection is located. I can do the same thing on the ground side of the relay. Oops. I got to go to the ground, minus bat, and my red probe on pin 85. Now I'm checking the ground side voltage drop of the relay coil, and I have 0.04. Again, that's checking the ground circuit, making sure the ground circuit's good. If I think I've got a bad ground connection, I wiggle the ground strap or tap on the ground connections, and if I have a faulty ground circuit, this reading will jump around when I wiggle that wire or move that connector. And of course I can do the same thing on the relay secondary side from FP1 up to the positive B plus, the positive battery post. Now you see I'm reading 0.87, and that's the voltage drop of the voltage side of the fuel pump circuit. And then I'm going to check the ground side voltage drop of the fuel pump circuit. Ground back to battery negative, and touch FP2. Now I'm checking the ground side, 0.05. So I have a good ground circuit as well. So you see the voltage drop of the voltage side and the voltage drop of the ground side. You practiced it with each one of the circuit boards, each one of these modules, to practice it over and over again, to understand it, be able to do it, because you can do these voltage drops of the voltage side, voltage drops of the ground side, and you don't hardly need a schematic or a diagram. You need to know where the battery is located and what circuit you need to test. And from those pins back to the battery post and the battery negative, you can identify the intermittent connections in the circuit. One of the things I want to mention about relay troubleshooting, which you're going to study, but I think it's something that bears a lot of emphasis, because when I've mentioned this before, I've often heard people gasp, "Oh, I didn't know that. Man, that's something I should have known a long time ago." Here's the point. Let's say I'm measuring pin 30 on the relay coil. Now this relay, everything's fine. The relay is energized on pin 30. I have 12.79 volts. Okay, that tells me that from pin 30 all the way back up to the B plus, the plus bat terminal, I have a good circuit. And what if I had a voltage drops problem here? Let's see if we can't do that. Okay, I have just inserted a problem here to illustrate what I was referring to a moment ago. Notice the fuel pump is dim. It's barely pumping any fuel, got no fuel pressure. What I've got is not enough to run the car properly. So I go to the FP1 and I see right away 5.7 volts. Well, that tells me I've got a problem on the voltage side of the fuel pump circuit. The ground side is fine, I got 0.03. So now I go back looking for my B plus. I go to pin 87. It's still low. I go to pin 30. It's still low. And I go to J7 pin B. Wow, it's good. So there's a voltage drop between J7 and pin 30. So I'm going to put my probe back on pin 30, and you see clearly that you have low voltage there. But notice what happens if I turn the relay off all I've done is switch the relay off. Now the circuit's still powered up. I use S3 to turn off the voltage to the coil so the relay powers down. Look what happened to pin 30. It went back to 13.34. But when the circuit is powered up, the voltage on pin 30 drops down. Because there's a problem, there's a voltage drop between pin 30 and B+. And as I trace back, I find it's right here between pin 30 and the next connector. There's a voltage drop here. Well, if I have the circuit powered down and I look at pin 30, I'm going to see good voltage there because there's no voltage drop. The problem is still there, but the current's not flowing, so there's no voltage drop. So the point is, whenever you measure pin 30 on a relay, make sure the relay is energized and the current's flowing, and then you will see the problem. Now one of those is, well, in fact there's more than one in those 75 problems. You never know when you're going to get that one. You just troubleshoot them, you trace the circuit, you find out where the voltage drop is, but since you're going to be doing it with the power on, you're going to see the voltage drop. But I've seen people, and I even admit my own mistake many years ago, I would measure pin 30 to see if I had B+ there when the circuit wasn't powered up. And I missed the problem. Learned the hard way. That's where a lot of these problems have come from. Actual troubleshooting and finding the problem. So let me remove the problem here and put it back to normal. Okay, the problem has been removed. I'm going to power up. The fuel pump is running great. I got good fuel pressure, and FP1 is good. Pin 30, you see, is running at 12.8. And if I turn the circuit off, since there's no current, it jumps up to 13.3. So this tells me that the normal voltage drop that occurs when the circuit is on is perfectly normal. You're going to have some voltage drop, but you have to know how much is enough and how much is too much. And that's what you'll learn as you go through these 75 individual problems. And remember, each one of these problems will have a customer complaint. This is how the car is acting, this is what's happening, and you troubleshoot the circuit and you will find the problem. So that the troubleshooting problem from the customer's complaint gives you some more realism into the purposes for which you are learning how to troubleshoot a relay circuit. So that's it. Keep in mind that the instructor guide that comes with the program has all the answers to all the exercises. It has all the answers to the troubleshooting problems and shows you how to insert a particular resistor or open a circuit for an open circuit problem by removing a 0 ohm resistor. And it'll just take you a little bit of time to get familiar with the location of the different numbers. Everything is plainly marked, very easy to find, and you will troubleshoot 75 different problems, and I can assure you, you will see everything that could go wrong with a relay circuit. Good luck to you.